Good evening, everyone. As we gather here for session 9 on this promising day 5, I want to take a moment to reflect on our journey so far. We have made incredible progress together, and your engagement and contributions have been invaluable. Today, we'll be diving into the topic of utmost importance in our digitally interconnected world, the security of artificial intelligence and the Internet of Things. The importance of IoT security cannot be overstated, and it is our responsibility to ensure that our innovations and technologies are safeguarded against vulnerabilities. So I take great pride and pleasure in welcoming our speaker today, a distinguished alumnus of our institution from our Department of Computer Networking, Mr. R. Madan Kumar, to this faculty development program. Your presence at this event not only enriches our program, but also serves as an inspiration to our current participants. Mr. R. Madhakumar is working as Senior Software Engineer at the Amazon Development Center, Bengaluru, Karnataka, India. He completed his schooling in RVG Higher Secondary School, Tamil Nadu. He completed his diploma in computer networking at PSG Polytechnic College in the year 2011. He received his Bachelor of Technology in Information Technology at PSG College of Technology in the year 2014. He served as software development engineer and senior software engineer in the companies like Microsoft, Amazon Development Center, and Intel Mobile Communications. He has 11 years of experience and he is an expertise in Java, data structures, and C++. Please join me in giving a warm welcome to Mr. R. Madan Kumar to this virtual stage to share his insights and expertise on security in AI and IoT. Welcome, Mr. Madan.
Thanks, ma'am. Thank you. Hey, very good evening to everyone. Thanks for joining. Folks, feel free to come on camera or ask questions, either be it in chat or anywhere. Let's get started. Right. I think Priya ma'am has introduced me, right? Like, let me give a little more background on me, right? What kind of work I have been doing over the last 11 years. So I have been working in predominantly Amazon, my experience, and some time in Microsoft and Intel, like ma'am mentioned. I do have some experience around working with IoT devices and AI, right? Which is being a core part of technology today. So I have some background around it. So hopefully whatever I'm going to present it to you today with my experience will be helpful. So about this particular session, right? Like, it's not a standard one. Like, I will go through slides. We will go through videos in between hands-ons. I will try to keep it more engaging as possible by giving you the structured ones. Meantime, if you have any questions, feel free to come and ask. I would encourage questions over audio, if possible. Come on video and ask questions. Let's keep it more engaging, more than theoretical sessions, right? Like, yeah, with that, we can get started. Priya ma'am, do you want to add anything before, or we can get started?
Start the session.
Okay, all right. Let me share my screen. Okay. Can somebody confirm me if you can see the screen? Okay, thank you. So this is a very interesting topic in today's world. I will go turn off my video so that you can see the screen completely. So it's a very engaging topic in today's world. I think everybody is using AI in one form or another, right? Uh, be it in software development, be it in college, uh, for studies, research, anything. Right? And IoT is also another aspect like which is being used almost in a lot of sectors today. Uh, be it we hear the terms like smart cities, smart uh, delivery stations, etc., etc. So in these presentations, right, I'll be more focused towards uh, how we are using AI and IoT in Amazon, right? Uh, Let me give you a background, right? So that it will be more helpful about the exact work which we are doing. Currently, I'm part of a last mile organization in Amazon, right? What is last mile? All of us go and order product in Amazon, right? Like it gets shipped to you at the end. That's the experience, But a lot of things happens behind the scenes. After you make an order, it needs to be shipped from the particular seller or from fulfillment center to you. There are a lot of sequence of things happens. The last mile is the place where you have received the package into the delivery station. Maybe there is a delivery station for your city or area where the package is received. From there, how do you deliver that package to the end customer? End customer who are you, me, everyone, right? Everyone who is making the order. So I'm part of the team where we are doing automations using IoT and in fact using AI in a lot of areas uh, to, to efficiently automate this process and also uh, make it valuable to us, right? So that some of the concepts which I'm going to touch upon, I will jump on to some videos and show you how it works today. Uh, I won't be able to share any of the confidential things, so I will be relying mostly on some of the online resources. But I will try to give you the high level picture how it works internally and all. So the agenda would be set like I will introduce you about. We will do some quick recap on what AI IoT is, what are the challenges, and when these two converges, that's what we are going to talk about, right? How to use AI-based security mechanisms in IoT. So when these two converge, what happens? And we are talking about theoretical, right? AI IoT, but when you actually go and implement this, what are the things you need to think about, and what are the things you need to handle, right, to efficiently deploy into any use case, and how we are using some of the AWS Amazon services, right? AWS Amazon services to help with this AI or IoT. You need to have some platform to build these things, right? I think AWS has a lot of good services in support of AI and IoT related development. Feel free to interrupt me or ask questions. I will try to answer whenever possible. In case if I'm not responding, you can uh, come on chat and come on audio or video and tell me about it. So with that, let's get started. Yeah. So you must have been learning about AI and IoT in last few sessions, but I will do a quick recap to set the context properly. Right. So we have multiple terms floating around, right? AI, ML, Gen AI, which is the recent hot hot topic, right? And LLMs. But it's important to slightly understand, at least at the high level, what exactly the difference is, right? So that whatever you're talking makes more sense. Everything is AI, by the way. AI is a very broad term. Uh, AI is a very broad term, right? Like we call AI in general. So this, how to say that AI is like a thing which thinks like human. Whatever human intelligence like is, wherever you require human intelligence, we kind of replace that with AI. So that system or computer or algorithm thinks like human and makes a decision or reasoning, problem solves. That's broadly we call it as a example, right? Like let's not be theoretical always. Like let's take example at each of the steps and understand it better. I believe you must have seen Google, um, Google's Google's voice assistant or Amazon's Alexa, um, Siri, all those voice assistant things, right? What do you ask? You usually do. You ask, for example, you take your phone, say, "Okay, Google, book a reminder for me," or set an alarm for morning 5 o'clock. These are some natural language uh, requests we are giving to the system in form of audio or voice, and that AI process that request and makes a corresponding action. Right? There could be so many factors involved. AI needs to understand what is a request. It needs to know what needs to be done for that request. And every time you are doing, it needs to analyze the pattern and also respond in a proper way. Right? It has a lot of things in place. Now, if you look at it, I can go and book the calendar, book the reminder by myself by going into those settings and whatever. Or I can schedule a reminder for, alarm for the morning. But that's a human activity which is being replaced by AI. You just issue a command to AI which does that for you, right? It's of course making things simple, but that's how the world is evolving. That's artificial intelligence for you. Simple. You can take any voice assistant, Alexa, Amazon Alexa, or Apple Siri, for that matter. Uh, let's say one more example, right? Like I told, the practical one which you are using every day. All of you must have heard about self-driving cars, autonomous vehicle, Tesla, uh, etc. Right? So how they are also interpreting data from various sensors or cameras and making decisions uh, without any human intervention, right? Like you're not doing anything there. Like it is making the decision, everything on it by yourself itself based on the data it has. Data is a key term here, right? We will cover more about it. It's like now these two examples which I gave, smart assistant or be it autonomous vehicle, both are like acting like humans, right? They're kind of replacing the human intelligence uh, with some kind of artificial intelligence. That's AI for you, right? That's been there. This term has been floated around for quite some time, but it's evolving. The AI is not uh, one simple term which you can explain. It's a very broad term to call out. So in field of computer science, it's about creating machines or software uh, which can perform the functions like reasoning, cognitive functions, right? Like reasoning, problem solving, learning. You can create perception, uh, language also, right? Like it needs to understand different kind of languages. It can respond in Tamil, uh, Hindi, English, whatever languages. Now, that AI includes, which also includes machine learning, generative AI, LLMs. Now comes the support of AI, right? Machine learning, which is a specially subset of AI. It's a focused on certain things. You create algorithms here, which is called ML models, you must have heard. And you train those models, and the model does the specific things, right? Like be it predictions, be it identifying patterns. It's a very focused area of AI. AI was a very broad term. ML is like slightly focused. And let's take example for ML also. For example, Gmail. You have spam filters. Some of the messages, email messages, goes into spam. How does it know it's a spam? That's a question, right? Or let's take Google search or Netflix or Amazon, whatever it is. You do see recommendations. Oh, you watch this movie, you can watch this movie, right? These are better suited for you, maybe, right? How these predictions are being made, how these patterns are being recognized, that's done by ML models. ML models is not a single one; it's a plural term, right? Like there could be so many number of models which you have come up with. Some will work for some sense, some particular use case, or meant for particular use case. It's not like one model works for everything. We'll have different kinds of model, uh, which is like dedicated for each use cases or specifically focused for each type of use case. So emails, I told you about two different use cases, right? Like email spam filters. It automatically you classify it as a spam and it moved to spam folder. How does it happen? Some ML algorithm is trained uh, with the data set of these are the spam emails. If it is labeled like that, move to spam. Or maybe even email addresses. Usually the spam email addresses are like this. It understands the pattern based on the data it has been given. What about recommendation system? Similarly, like it also has data. It also understands about the data, your usage history, all the kind of data, or regional data, right? The ML models are trained with those data, and it makes a prediction. Okay, you like this, you may be liking this movie also, based on so many factors. It's not a single factor, right? Netflix will have its own model, own recommendation system. Their algorithm might be different. Google's algorithm might be different. Amazon's algorithm might be different. So it's the efficiency of those models depends on the kind of data which they are given, or the amount of data which has been used for training, the quality of data which has been used for training, and how they make the decisions also. Right, there are a lot of factors. I will come to that one by one. So that's machine learning for you, right? Now comes the subset of machine learning again. It's a Gen AI. I think every one of us must have heard Gen AI in recent days. If not, you should definitely read about it. It's one of the hottest topic in the market today, where it's transforming our everyday life work. If you want to give a specific example, right? Like even in our meeting, you see AI companion at the Google Meet, right? It's one of the AI element, right? It's been integrated in this Google Meet also. So AI has been reaching us in a lot of ways. Well, I just told you one example. I hope people must have heard about Chat GPTs, Amazon Q. There are a lot of online platforms available today. DeepSeek, that's a recent news. So these are like generative AIs, basically. You give the content, you kind of interact with them, converse with them, give some input, prompt. It will generate those content for you. Content, I mean, it can be a text, audio, video, anything, right? So yes, of course, again, these are models only. It will have different, maybe text, there is a different model, audio, there is a different model, video, there is a different model. But yes, ultimately, there is a generative AI model which is doing the stuff for you. It also needs to learn from the data, existing data, and it needs to understand what you're conversing with. Um, then it needs to provide a response. Right? That is also there. But Gen AI is again focused one in machine learning, where you focus on creating content. Right? These model create some content for you, be it text, be it audio, video, or images. So GPT-3, that's a Chat GPT is one of the example, right? Like that's also a generative AI. You ask the question, what is the capital of France, right? Or what is the capital of India, or whatever questions. Uh, Explain me about this. It would reason that language, try to create the response based on that, right? Based on its it would learn the question from us, and it will decide what are the possible responses based on various factors. The Gen AI model will do the stuff and will give the final response to you. This is literally transforming our industry, our day-to-day life. And uh, I will show you some examples post this, right? Like how Gen AI is. Now then comes LLMs. It's again a subset of Gen AI. Um, which is specifically about human languages, right? Like you kind of can't ChatGPT and all, which I told, which are LLMs basically. GenAI is slightly high level, Uber level picture. LLM is a very focused thing, but still you can merge this also. It's not a big deal, but LLM is a subset of GenAI. So it generates human like text, video, languages, summarizes, a lot of things it does. Yes, so that's about the AI. You must have read from the previous sessions and all, but this is a quick recap before we go into how AI is working for us. Now let's see. Let's not be theoretical. Let's go and see how AI works, right? How Gen AI is transforming your activities. Some of them you must have noticed. Some of them I think I would show you new. First one, let's say reading and summarizing web pages. You can see my screen, PPT, or what? Let's confirm that once. PPT or some different videos. Which screen you are seeing? The screen which I'm sharing. Are you seeing the YouTube? Can somebody PPT? Now is it Chrome or Chrome? Great. So then it works. So Gen AI, the topic which you are talking about is Gen AI, right? It's transforming our everyday lives. So let's look at some of them, right? Like first one is reading and summarizing the web pages. Let's go and see what it means. So just go Wikipedia. Let's not go here. Let's say artificial intelligence. Search about it in our Google, right? It gives a lot of things. Let's open Wikipedia. Oh, I have so many pages, right? How do I read? I used to read like in earlier days, it was like, oh, you go paragraph by paragraph, understand what is this. Maybe some of them here is like not even valid, right? Like not even relevant to us. Maybe valid, not relevant to your research. So you want to look at the summary. Let me summarize this page using Amazon Q. I'm opening a Amazon Q. That's a Gen AI assistant for me, which I have installed with Chrome, which is publicly available, by the way. I'm just clicking on it. This page, I want summarize. What it is going to do, it's going to completely understand this web page and summarize that for you. Just give me a second, some authentication. Yes. Is it summarizing? Yes. Let it do the job. So you can see there are so many things which we talked about when I searched about artificial intelligence. But I'm not interested in learning all these things. It will take time for me. I want a small summary, right? Let's see. It summarized. This Gen AI understood this complete page and gave me a simple summary, right? Like, okay, these are the key points which you need to look at and the questions you might have, right, for further follow. It is becoming intelligent, or it is the way we are reading the web pages is changing, right? Now it is suggesting you the way. So it is simplifying things for me, basically, right? It is easy for me to understand. Oh, this is not relevant. Let me go to the different. It's one simple example which I told. Hope that makes sense. Uh, Now that's reading and summarizing web pages, right? It's a day-to-day thing we do that. It's changing with Gen AI, right? In fact, we may not even go and do that search. We will do that search in, um, let's say, ChatGPT. Must have heard, right? That's another. So what is Deep Sense? Let's say this is a new Gen AI thing launched in China. Let's see what it gives. I haven't tried that. it is conversing with you, right? Like there are deep sense. This one. Let me ask about this. You don't need to do Google search these days, right? It's kind of replaced by this generative AI platform. You give the thing, it it identifies the information and gives you that very well. Uh, so this is how that it is changing our life, right? Like now you can summarize the pages in case if you are browsing something, or in fact you go and ask the chat as personalized chatbot, right? Or assistant. The one which you invent is the chatbot, where we ask things, it is responding to you. Okay, these are two examples, right? Like let's go over the second one. It's not only about reading, right? Like it's all about I'm a software development engineer, right? Like I do coding every day. How it is changing my day-to-day coding thing. Or even if in colleges you must be doing some coding, how it is impact, how it is changing. Let me open the IntelliJ and show you that. Just give me a second. What I'm getting to is like Gen AI is involved in everywhere. We are day by day we are using that, and it's making our job easier. I'm just opening the particular IntelliJ thing for you to showcase. Or I'll come to that IntelliJ thing in a while. Uh, AI is assisting us with our coding, right? I'll tell you, it will be really helpful for us to use that, leverage our and improve ourselves in terms of coding. Or be it maybe it took 1 hour for you to do some coding. Now it becomes very simple, right? You can do it in 30 minutes with the help of AI. So that's how it's evolving over there. Look at AI generated videos, right? Maybe I want to create a reel with AI, right? You don't need to open Photoshop or some video maker to generate videos. I give you the text prompt, oh, generate this video for me. AI might understand and generate the video for you. I was recently doing some experiment around that. Let me show you that. So this is an Amazon Bedrock service, which is a Gen AI platform where let me play this, where you can see this Bedrock is a service provided by AWS. It's a Gen AI platform. I'm giving some input, right? So, oh, I have given some prompt. Yeah, associate is working on this. Give me that. This is a reference image. It needs to generate a video for me, reel for me, right? And it is generating. Let's see what it generated. If you look at what I'm asking, an associate is working there. The packages are coming in built. Uh, uh, just you need to pick the package, right? That's the input I have given. The platform understood this, but taken the reference image. This is an overall reel is the model. See, this has generated the video. You can see that video has been generated. So it generated from nowhere. Let me go back again, right? So you gave some inputs. Okay, this is a reference image you can use. This is a prompt I have. Generate that video for me, a reel for me. AI took this, generated that video, and that video has been played, right? Like this is completely generated by AI. There might be mistakes which will course correct based on the further prompts and all. this I have done some experiment for one of the recent project. So AI can generate the videos for you, right? Uh, you don't need to do everything by your hand by yourself. In fact, updating this video is also simple, right? I have this video, update this section for me. It will do something and update it for you. Of course, you need to give proper prompts to do that. And I showed you about chatbots already, which is helping you with writing anything. Or you want to write a document, you have written something, you can even ask those chatbots, okay, check this sentence. It will create and summarize things for you that you can put it on the board. So writing is also changing. Writing, writing and coding, everything, right? Like day-to-day things are changing. You would see applications of AI almost everywhere, and it's even be going far. We are going even fast with Gen AI into picture because it is making a lot of things even more efficient. That's how it works. Let me go back to IntelliJ again to show you how it helps with coding. Yep. What I'm sharing you here is a IntelliJ IDE. You could be using Visual Studio Code um, or anything, right? NetBeans or whatever it is. So it's one of the IDE, right? IDE, so integrated development environment, where I have written something, some random stuff for one of the project, right? Now, what happens? You wrote this code. What used to happen? You write this code in a way that you think of each of the every corner case. You write this. Maybe you have written this code. I have a Amazon Q installed here, right? It is integrated with this IntelliJ platform. As I said, Amazon Q is a Gen AI platform. It's a LLM-based model which Amazon has developed. It's giving us a service called Amazon Q. And I'm going to ask this. I have selected this code. Let me know there are any issues. Right. It is literally checking my code, right? Whatever I have written. Oh, looking at your code, there are few potential issues to address. You need to address this, you need to address this, you need to address this, right? It is able to understand my code and giving me what are the things to be done based on some other best practices which I to understand. See, it is transforming my code. So now if I would imagine, my college projects would have been much simpler with these, right? Um, I, I don't need to understand completely. I can give you the high level idea and I can give inputs to this Gen AI. It will generate the code for you and you can make it work using that. Let's do one more step, right? Like just and update the code to follow better standards, better coding standards. Let's say. So now this is the code we have. This is a simple code which I have written some simple functions. See, it is making a lot of changes. For instance, it's instead of class main, it has created a proper name for this class. It has created constants, separated the functions, added proper Java docs. It made this code very beautiful, right? Like it has separated things. So that's how it is changing, right? If I was right, there are few things. AI can suggest you things while writing, and like this you can check, you can cross check with AI, right? Am I doing right or anything to be in it? I'm not saying it's perfect. Whatever it is giving is perfect. You still need to understand and make the corrections and all, but it is able to guide you there, and it is helping you. So it's been effectively used by all the software engineers as of today into their life. So where they write some code, get the help from AI to enhance it, or writing some redundant works. uh, and get even we can move on faster and deliver things faster, right? That's how it is evolving. Now I gave you a real life examples, right? Like how Gen AI is evolving. But yes, of course, there are some challenges or issues with that also. You ask some things, right? Like now whatever I told you is like not a very secure thing. Maybe I might be asking something related to medical stuff, medical histories, something confidential, right? So the data security is an important challenge, right? Like you are relying on Gen AI to not um, breach the security. We, as a users, we expect some security, right? Like, for example, let's say Madan, right? I'm Madan. Uh, I'm doing some query search about something about my personal stuff or confidential project which I'm working on. Let's say you go and ask the ChatGPT, what did Madan search about? Right? Should it give the data? No, it shouldn't. If it gives, then it's violating the privacy of mine, right? So security and data privacy, data security and privacy is are event because we are relying on AI, what it is, how it is doing, what it is doing. We don't have control, right? Like you are giving some input, it is giving you some output, but can you trust the AI completely? Maybe not. You still need to do a lot of evaluation before picking up the things. Uh, and may, in other words, just don't share privacy related things, some private informations or confidential informations to the AI. Maybe you can keep that out when using AI. So again, in security also there are different kinds of uh, risks, right? All these are models. So you give some input request, it will work on that request and give you some response. That's how AI works. For example, it responds based on the data which has been used for training. This is a model. It has been trained with history of data. You ask something, based on the data, it analyzes something and gives you the results. What if the input is itself is wrong, right? Uh, so that is there. So how you train the data, what kind of data you're using, quality and quantity of the data, diversity of the data which you're using to train the AI is important. I will give more and more examples there as we go on. Uh, Now, adversarial, the data should not be leaked, right? Like, and it shouldn't reveal me who is doing what and all. It should have established some. That's a risk with AI, right? Like, you need to be confident when you are using these. And there could be other areas also, right? Like adversarial attacks. What I mean by that, you can train the models in a way that AI is deceived. Uh, that model doesn't have the complete picture. Let's say you're training that model only with data from Tamil Nadu, right? But somebody from US is querying the Gen AI, which is better place to travel or whatever it is, right? AI will be giving data based on this regional thing. It's showing a bias, right? Because the data which is being used for training is only for a particular locale. It doesn't have information about all the locale. So AI doesn't know, is it relevant for this guy? Question I'm asking, is it relevant for the person who is requesting me from Tamil Nadu, or is it relevant for the person who is requesting me uh, from US or some foreign countries, right? Like that kind of bias is there. So that means what I'm essentially coming to is like the data can be uh, AI can be trained in a way the models are deceived to make incorrect predictions also, right? So that also is a threat, right? Like how do you train those models, uh, and how do you make sure that it is going to consider all the data, everything. I'll talk about the solutions around it, but yes, that's a risk, right? If you're not training the model correctly, then it's going to give you wrong output or biased output. And given the model theft, reverse engineering, somebody can reverse engineer that model, and uh, so how they may be basically they are trying to understand how the model works and find a loophole to attack that model, right? Like give some queries or request in a way it can compromise our security. Those are also serious things. Now, why I'm calling about these things, right? Like we are talking about using AI for security, right? If you are talking about using AI for general things, okay, question and answer, summarization, the problems there is fine, right? It's not a big impact. But using AI in security comes with a heavy responsibility on us. If it is not working well, then you are compromising the entire system, entire use case. That's why I'm calling out this specifically. These are challenges and risks, right? The kind of model which you're using, it should be good enough to handle that security related use cases. The kind of data which you're going to use should be should be of quality data, diverse data, so that the model can function accordingly. Yep, given we have talked about a lot of um, challenges here, right? Okay, so what we can do um, to increase the security, right? First thing I called out data security and privacy risk, right? Differential privacy. What I mean by differential privacy, I can give you an example for different privacy also. Um, so I'm your AI is going to, of course, AI going to use the data all of us feed in, and it is going to generate the data for some user. You shouldn't feed in the data which will give you which will let you which will let you expose yourself, right? Like, for example, I may not need to share my date of birth. I may not need to share my bank account details and all those stuff, right? Like those things are not necessary for the AI. So, and even if I had shared, it should be it should not be identified pointing to me, right? Like AI should be able to have differential privacy. Okay, the whatever information it is going to give out, it shouldn't pinpoint particular user or particular group of people or whoever it is, particular system. It can be anything. So it should have a capability to differentiate, provide a differential privacy. That's what I mean. So individual data points should be protected. First of all, it should not be allowed to train with the individual data points, but it should be protected even in case if it is given. And the training data and models should be access control, right? Like um, you give some data to the model, you should be sure that that model is a authorized one or the actual one which you want to use. There shouldn't be any provision for you to modify that content from external unknown party or unauthorized party. That should have a general access control and encryption mechanisms. That's a common one, right? And when the way you are collecting the data should also be secure and proper. You might collect data from so many places, but how do you know the authority of or validity of the data, right? You need to make sure that the privacy considerations are there, what kind of data you are ingesting in. Those things we need to be very careful. If it is a closed environment, yes, you can achieve it well. For example, let's take Amazon delivery stations. I told you about last mile, right? Here we have a specific delivery station where all the things happening inside the delivery station are not are kind of encapsulated, right? Are segregated. We don't need to get interfered with other kind of data. So in those environments, it's much easier. So the examples which I'm going to share with you are like very specialized use cases. How do you use AI in our delivery stations to effectively deliver the packages faster? Uh, those kind of scenarios are fine, but when you're thinking about, let's say, smart cities, AI will change the smart cities. Right? Like it will IoT and AI will be part of the smart cities where things will be like more digital and all. Like there, these kind of things takes much more importance. That's what I'm coming to. I explained about that input sanitization. You need to know what you're ingesting into the AI. Unless you are training with the proper data, it won't give you the proper output. And the model should be strong enough. It shouldn't show any bias and all. And we should have checks and places where misuse of this AI is prevented. And you can't let everything with AI. There should be some human oversight also, and frequent auditing is required. So that's a general thing, right? These are some of the common solutions which you implement. These are terms which I'm calling out, but internally, each each use case might require different kind of solutions. I will discuss some things around that, but with these concepts, you need to implement based on the use case. May differ from smart city related use cases, might differ for coding related use cases, might differ for delivery station related use cases. So it's a very broad theme. I'm giving you a solutions at the high level where we can use, we should use when you're using AI for security, because this takes the first priority when you're going for security. So what I'm going to do, I'm going to play a video, which will be interesting for all of you guys, hopefully, where how it is being used in our delivery stations. I'm going to show you now. Playing that. So you folks can see the video which I'm sharing. Can somebody confirm? I'll just.
Building sorts those packages, then they flow out to our delivery station.
Can somebody confirm? You can see the videos. Okay, great. You can hear the sound also, right?
Inside this 1 million square foot warehouse in Northern California, Amazon packages are handled by hundreds of.
I hope you can hear the sound. If not, let me know. I'll see what else can we get. I'm playing this video. This will give you what happens inside a delivery station or fulfillment center, how we are using AI and all.
So fulfillment centers ship into this building. This building sorts those packages, then they flow out to our delivery station.
Inside this 1 million square foot warehouse in Northern California, Amazon packages are handled by hundreds of people and hundreds of robots, all increasingly driven by tech's biggest craze.
Generative AI underpins everything we're doing here, with perceiving, grasping, and moving products with the Robin arms to managing fleet congestion with our Pegasus robotic drives.
For years, Amazon has sped up package delivery, 2-day, 1-day, and now more and more same day, made possible by more workers, but also by rapidly improving algorithms and AI-enabled robots.
What you see here is, I like to call it our dance floor.
And thanks to being an online retailer from the start, Amazon has a big advantage when it comes to the massive data needed for generative AI.
Absolutely. Amazon has been better at it than probably every other retailer out there.
Think better predictions of exactly what you're going to order from where and when, hundreds of thousands of robots, and more efficient delivery routes. But not all the change that could come from generative AI is positive.
In the event that they were able to leverage generative AI and fully automate the fulfillment center, I think that would be problematic. The other downside that we don't talk about enough is the negative impact on the environment. The cost of running data centers, the use of electricity, the use of water for cooling.
Still, Amazon says AI helps cut costs and its carbon footprint thanks to more efficient planning.
It seems subtle, but at this scale, getting like just one more product in the right spot means that it's shipping less distance when you order it, better speed, lower distance travel, better sustainability.
CNBC visited Amazon's largest California sort center and a same-day warehouse nearby to see firsthand how it's putting AI to work at every step of operations, and sat down with Amazon's head of transportation technology to find out just how far the e-commerce giant plans to take it. When Amazon Prime launched in 2005, 2-day shipping was virtually unheard of. And although it's now standard and free for millions of items if you're a Prime member, it's a grueling logistical lift.
Along here, you see Robin arms, which are robotic arms. They're loading packages with employees onto Pegasus drive units. Those Pegasus drive units are then sorting packages by neighborhood.
Steve Armato started at Amazon as a software engineer before Prime in 2001.
A lot of things you see today, those weren't there in 2001. We had 5 fulfillment centers back then. Now we have hundreds. The delivery vans that you see in the neighborhood, none of that was there.
Traditional retailers like Walmart and Target were selling online, but they hadn't started making promises of speed.
Back then, mail order, when Amazon started, you'd be lucky if you could get something in 2 to 3 weeks. And, Amazon would still promise like a week and they would get it to you in a few days. So that was amazing.
So how did Amazon pull it off? The short answer is data. Long before generative AI became all the rage with the release of ChatGPT in 2022, general AI was a huge differentiator for Amazon. As an early online-only retailer, Amazon had a unique ability to collect mass aggregate data on shopping behavior and use it to create algorithms to maximize sales and speedy logistics.
We've been working on AI over 25 years. For employees, a lot of it is around ergonomics and safety. For customers, it's around vast selection, great speeds.
Exploiting technology to drive e-commerce sales. That's essentially what Amazon's done since '97, since the beginning.
They are, I would say, hands down, the most data heavy and data savvy, company. It's not that Walmart and Target and Costco and others don't have their own reams of data, but they're looking at things a little bit differently, and they have much older systems.
Amazon is decades younger than its major retail competitors, but its stock value and footprint have grown incredibly fast. Hundreds of warehouses, more than 1.5 million US employees, and more speed. In 2014, Amazon launched Prime Now, with some deliveries arriving in an hour or less. Then in 2018, Amazon vastly increased its driver network with the launch of its Delivery Service Partner program, where it contracts driving out to some 4,400 small delivery businesses that employ 390,000 drivers. By 2019, one-day shipping was the norm. Then in 2020, Amazon began using transformer architecture, the backbones of what we know of today as generative AI, to develop models for demand forecasting and supply chain optimization. By 2022, it was rolling AI transformer models into its robotics. All that made shipping times even faster. Today, drivers are delivering 20 million packages per day across 20 countries, and in the first quarter of 2024, more than 2 billion items arrived the same or next day.
60% of our deliveries for Prime customers in March were same day or next day. So there are a lot of those fast orders for our top 60 metropolitan areas.
Could you have gotten to that 60% number without generative AI?
Well, I think we've been working on this for decades to get to this speed. And it's a combination of engineering, people, processes, and technology. Generative AI is a big unlock for us, particularly for new products, where we have sparse or no history for that sales history for that product. It's going to come faster because of generative AI.
Powering financial solutions that transform industries. Powering seamless execution in evolving markets.
So while this ad loads, so what you are seeing here is like AI and IoT are used, are heavily used to make these shipments deliveries faster. We have progressed from multiple days it takes to delivery to single day delivery. Even now, we are going in the direction of delivering within hours or minutes, right? Within same day, we are trying to deliver. So a lot of AI and IoT related stuffs are helping these associates to work faster. You can see even in this video, right? You can see a lot of things are happening. So there are some IoT devices involved. You could see lights blinking there. You should see packages being diverted automatically. Those are IoT devices, and robots are moving from one place to another. And there is a lot of processing, ML processing behind the scenes, which is an AI, effectively, Gen AI based MLs or whatever ML models we have. AI and IoT are working together here to make this possible, right? I'll play the video again. I'll come back once. This is what.
You have sparse or no history for that sales history for that product. It's going to come faster because of generative AI.
But all this speed comes at a huge cost in actual CapEx, but also human labor, a burden that can be reduced, Amazon says, with the use of robots.
Before robotics, pickers would need to walk distances between aisles to pick products, kind of like a library. And now it's being brought to you more like self-service. And so that's great for ergonomics. It's great for less walking.
Amazon has faced scrutiny in recent years over its workplace injury record, with federal citations for safety violations and a year-long Senate probe that found Prime Day was a major cause of worker injuries. Amazon has appealed the citations and said the report ignores progress it's made, and it says AI can help.
One algorithmic improvement is to take our faster selling products and place those on the shelves at waist height. That's your ergonomic power zone. So less reaching, less bending.
Amazon's big shift to automation started in 2012 with the purchase of Kiva Systems for $775 million. Now, Amazon has deployed at least 750,000 robots, more than double the number it had in 2021.
So generative AI helps with prioritization. So some of the 2-day deliveries might stand aside and let the robot with the next day delivery go on its mission first and take a straight line to its destination.
Amazon's next generation of drive units, called Proteus, are fully autonomous.
They're actually outside of this fenced area moving things around. They're using generative AI and computer vision to avoid obstacles and find the right place to stop, the right place to park.
And then there's Robin Arms, which Amazon says have handled some 2 billion packages so far.
Would these 20 Robin arms be able to do what they're doing without generative AI?
I think that we would see that they would require a lot more training. And so generative AI has been really a step function improvement in being able to infer from our vast product catalog about how to handle a given product, even if I haven't seen that product before.
And although it's only in a couple warehouses for now, there's a humanoid robot called Digit that can grasp and handle items in a similar way to how people can. And Amazon has a new deal with AI startup Covariant, hiring its founders and licensing its models that help robots handle a wider range of physical objects. Of course, this brings up the big question. Could Amazon one day replace all warehouse workers if AI helps robots get too capable?
There's kind of a balancing act for Amazon. How can they implement automation to improve efficiency and manage labor expenses, but how can they do it in a way that complements their use of humans and doesn't replace them?
Amazon says the robots work with people, and they're creating new roles.
We're investing over $1.2 billion to upskill more than 300,000 employees by end of next year.
One study found that each robot adopted in manufacturing replaced about 3 workers. Other research shows that companies that deploy more robots add more jobs overall.
So someone needs to maintain this if it breaks down, or if something does get dropped on the dance floor, we have a process and special training to go clean that up. And so each of those creates new categories of jobs, some of which have higher earnings potential as well.
The truth is, at the end of the day, Amazon's responsibility is not to employ, kind of a million Americans, even though it does. Their responsibility is to their shareholders.
Another big way to please shareholders is to cut down on the huge amount of time and money it takes to get inventory from sellers to customers. To do this, Amazon has always used algorithms to predict how much of what inventory is needed, when, and where.
Every product has like a regional nuance. We recently regionalized our entire national network. And by doing a regional network, that means that products are more likely to ship from fulfillment centers close to you.
What's new with generative AI is the ability to predict where to place brand new items.
So we're able to use generative AI to create a link between products we have seen before, where we do have a sales history, and a new product we haven't seen before yet, and get it in the right place the first time. So when we place a product in the right place ahead of time, before you click buy, it's traveling less distance, which is a win for speed and sustainability.
Amazon also says AI is helping sustainability with a specific model that makes better choices about which packaging to use, and by reducing the number of damaged items that get sent to and returned by customers. Amazon says its AI is 3 times better than humans at identifying damaged products.
We ship billions of packages. We have the data about those packages. So we're able to use computer vision together with generative AI and that vast product and package data to then detect damages, and being able to sideline a package if we think it might be damaged before we ship it to a customer.
Powering financial solutions that transform industries. Powering seamless execution in evolving markets. We deliver our entire global bank to power new possibilities for you. Barclays Investment Bank. Powering possible.
But training and running Gen AI is itself a carbon-intensive process, a fact that could make it hard for Amazon to achieve its 2019 climate pledge to reach net zero carbon by 2040. By 2027, AI servers are projected to use up as much power every year as a small country. And Amazon Web Services has data centers filled with servers running AI workloads. Although this also gives it an edge over other e-commerce players because it can train its AI in-house. Amazon's also invested $4 billion in AI startup Anthropic, which makes chatbot Claude, a competitor to OpenAI's ChatGPT. And Amazon makes its own AI-focused microchips and its own generative AI tools for developers, which are used in operations.
We use tools like Amazon Q.
So I was just showing a demo of Amazon Q, this one on Bedrock, where I was showing you the demo where we generated a reel based on the given prompt, right? These are some of the services which are available within AWS, which is helpful with, which are generative AI and AI based.
To Amazon Bedrock, that allows us to evaluate different models against the, what does good look like? So what are the metrics for success of this business application?
One big metric for success that shareholders are watching: if Amazon's huge investment in Gen AI will translate to profits.
I have yet to see huge lift in anybody's retail business due to generative AI, including Amazon. I think that a lot of their biggest impact has happened because of the earlier investments, not necessarily some of these more recent investments. I've seen a lot of hype, but no actual numbers.
One area Amazon is hoping Gen AI will translate to true savings is the most expensive part of the delivery process, getting that package the last mile to your door. Amazon's now using more than 20 machine learning models to figure out the most efficient routes for its delivery drivers.
If there is more congestion on a road or if a road is closed, AI is able to help us determine whether that diversion is still there or take that different route.
In 2021, CNBC talked to Amazon drivers about the pressures and pitfalls of the job, from dog bites to urinating in bottles to save time.
People are running through stop signs, running through yellow lights. Everybody I knew was buckling their seatbelt behind their backs because the time it took just to buckle your seatbelt, unbuckle your seatbelt every time was enough time to get you behind schedule.
The hope is, with better routes and vehicle coordination, drivers will feel less pressure to cut corners or skip breaks.
It should enhance the driver experience, but it'll still be challenging.
In 2022, Amazon also rolled out new fully electric Rivian vans and now has 15,000 of them across the US. They're equipped with large screens where the new mapping and routing is displayed, as well as AI-enabled cameras that watch the road, sides of the vehicle, and the driver.
There's no camera recording if the driver's not driving, and there's a privacy mode.
Another area where privacy often comes up is around the huge amount of data it collects on shopping behavior. Now with generative AI, that data can be used to generate better, hyper-personalized product recommendations to a shopper, thanks to new developer tools like Amazon Personalize.
What do you say to people when they're concerned about their privacy or that it feels creepy that Amazon predicts their shopping behavior so closely?
Well, we're looking at aggregate sales history. We're looking at geographic regions and their behavior. If a particular customer were in San Francisco, it's not about that one customer, it's about what the aggregate behavior in that area is.
Sellers can also use Gen AI to write more targeted product listings or to generate images of their products in different seasonal and lifestyle settings. For shoppers, last year Amazon.com started populating with AI-generated review highlights.
Any product that you look at is going to have reviews, hundreds or even thousands. What I love about AI review summarization is it gives you just a couple of quick bullet points. So that's helping me make a more informed buying decision.
And in February, Amazon launched a new Gen AI-powered conversational shopping assistant called Rufus to further streamline those product recommendations.
Some consumers may be put off by product recommendations that are based on their purchase history. Now, Amazon may have to, if they don't already implement an opt-out, some sort of feature where a consumer could say, please don't look at my purchase history when giving me recommendations.
Despite concerns, Amazon is committed to injecting generative AI into every possible step of operations to boost speed, efficiency, and eventually, it hopes, its bottom line.
If you can reduce packaging, is that a good thing? Yes. If you can reduce the amount of time and the amount of miles you have to travel to get from point A to point B, is that a good thing? Yes. These are all good ideas, kind of definitely feel free to show us the receipts at any time.
So hope this video gave you a good picture about how Gen AI or AI helps in Amazon delivery, right? You can see how we have evolved from to the delivery speed, be it safety, everything. So the bottom line of this video, there were a lot of IoT devices involved in this process. you would have seen robots. That can be an IoT device, right? You have seen robotic arm. That is also an IoT device. You have seen conveyor belts. You have seen LED lights. You have seen scanners. A lot of them. All those are IoT devices. They are going to communicate some data to internet, or they will communicate with the system where the decisions are made based on the things are being automated. So, you can hear me now? Is my voice still low? Just a second. Is it better now? Cool, great. So what I was saying, the bottom line is there are IoT devices involved. There is a AI involved. All of these things work together in delivering for our customers. In basically, we have, as you have seen, we have evolved over the years with AI and IoT, which is helping us to deliver the packages faster. Right now, we are talking about same-day deliveries, hourly deliveries. All these things are possible with this AI and IoT device. I will go into IoT challenges, right? The IoT device I called about, I will go a little fast now. So the IoT devices which you have seen in that video, for example, LED lights, right? Like when you scan a package, an LED light comes up, which is important for you to, which is helping you to keep the packages in that particular rack faster. It's like a library, right? Bookshelf, where each shelf is expecting certain books. And when you scan a package, that LED will come up, which means that you need to place the package there. It is helping it indirectly to keep it faster. So that's how we are optimizing things, which is happening, which is making the delivery faster. Right. So yes, we have talked about AI challenges. One of the main thing, privacy, we called out. We called out a lot of things. There is a scope of error, bias. All these are challenges with AI. Then there are. It's not like IoT doesn't come with any challenges. IoT also comes with some security challenges. For example, you should be able to trust the device, right? Like that means the device should be an authenticated device. Not any device can communicate with you. So it's the device authentication plays an important role. How do you authenticate a device? How do you securely boot up the device so that no malwares are present? That's one thing. Right. And maybe you can think in other way, like what if somebody is man in the middle attack? You would have seen, right? Like what if somebody is eavesdropping things and behaving it like a device and creating a bad environment in that. So it means you shouldn't allow any external parties come into the picture. You should have proper network security layer, which doesn't allow external communications, doesn't allow unauthorized access or communication, right? That's also there. So that's also another challenge, right? Like how do you allow only the devices which are authenticated, and how do you allow the packets which are secure enough to work with our use case, work with our model? And we talk about a lot of data, right? These data need to be processed somewhere, maybe within a computer sitting in the delivery station. Let's take the delivery station as an example, right? Since we have seen the video, there might be a computer sitting in the delivery station which is processing all those, right? Or there might be a computer which is in cloud, EC2 instance or whatever it is, AWS cloud, Azure, whatever it is. They also need to process those. How do you securely transfer those data, right? Without any intermediate corruption or changes in the data. Integrity of the data should be maintained. And you should do that fast. It's not like you take your time, you have all the time in the world for the processing to happen and come back. You need to come back with a response, right? No, it also needs to happen fast. Latency is a critical aspect. For example, you're scanning a package, immediately the light needs to blink. If it is blinking, the light is blinking after 5 minutes, it is of no use, right? Like latency is also a big thing. That means data security is also a key role. How IoT receive or send data, right? That security is also important. And there might be critical, even our phones are getting critical updates every now and then, right? Like our Android or iOS updates are there. Similarly, IoT devices also require updates, right? these firmware updates, software updates, security updates. How do you are not going, we are talking about thousands of devices interconnected, and working with our AI platform to make this happen. So it's not like you go and update each and every software by on your hand, right? Like, no, it's about securely updating that over the internet or remotely updating, right? It should be an automated process, but we should also be sure that how we are deploying those softwares properly, like with integrity, without any attacks or anything. In general, you can't trust anything, right? Like, it's all trust factor. Like, you won't be able to trust any of the devices. There needs to be checks and validations in places to make sure things are working in place. So with IoT, it's not easy. When IoT itself has so many challenges security wise. Now, going to the solutions, right? Like, yeah, so how do you address these challenges with IoT? Yes, you will have device authentications, where IoT devices would be having the secure certificates, which will make sure that I'm an authenticated guy, and it will have a secure boot sequence. So it can boot up properly. That's one way of handling the device authentication. Then network security, right? Like, you don't send the blind data, maybe send encrypted data, and have proper firewalls in place, proper intrusion detection systems in place. You might have seen that in a small sense in any of the network which you have, maybe college network or maybe home network. You have firewalls in place. Even computer has firewalls, right? Like software firewalls. There are hardware firewalls, software firewalls. There are a lot of access control list, right? Like network level, you can do a lot of security aspects, so that intruders are avoided, and you can be sure of that integrity. And these things help when it's external. There can be internal intruders also, right? Like maybe some unauthorized device comes in to the network and start trying to communicate. So that's where network segmentation also plays an important role. Like, you don't trust anybody, create a segment. Or maybe this group of LEDs only can are allowed in this segment, and this robots should communicate in a different network segment. They are basically different subnets. Let's say this is one subnet, that is another subnet. So it's kind of isolated. The communication between them, again, mandated by rules, firewalls, whatever. Now, yes, this is about the network security, right? Like latency. I told about latency also. So how these latency concerns are addressed? Like I gave you an example where the computer itself can be in a delivery station, so it is very near, you can process it. If latency is not an issue, the computer can be that particular software or machine learning can be hosted in cloud. I'll cover a little more details on that as we go forward. So I'll move forward. And over there are air updates. There are secure ways of doing that. Again, you need to have proper auth and all in picture. Basically, the solution is don't trust anybody. All with a pinch of salt, doubt everything. Create a solution which is like segmented, properly authenticated. Lot of checks in place when you're thinking about IoT devices working with AI, right? Because IoT devices are giving you sending the data or getting the data to or from AI models, right? Like the data which is sent by IoT devices can be used for training the AI model also. So that's where it's important. Okay, we talked about IoT and AI in separate terms. Now, I can even show you how IoT things are modeled in our delivery stations. I'm opening an AWS console, AWS account, where we have these IoT things. IoT means these LEDs, which you have seen in the videos. The LEDs, which you have seen in the video, and be it conveyor belt, be it robot, anything, right? All these things are modeled as a IoT client. So basically, we are tracking them. We are discovering them, tracking them. All these things we are doing it from our AWS console. We can't go and check each and everything manually, right? We should have some tracking mechanisms. That's what I'm talking about. Let me go to one of the account to show you what it happens. AWS provides a lot of services for IoT and AI. We talked about Bedrock, SageMaker. We have seen some things in the video also. Those are for AI, right? But we have specific services for IoT, that is AWS IoT. Now, I have entered the AWS IoT account. Okay, so here you don't see anything. So what essentially what it means, I'm not showing you the exact one for confidential reasons. So these are things in our AWS IoT services. Each of the IoT device can be configured as a thing. So you would have access to that here. So you would be able to deploy software to that thing remotely, securely. You don't need to solve everything. Some things are solved by this AWS services, right? Like you don't need to solve authentication, right? There are existing platforms which can solve those things for you. You just need to pick the right one to use for the right thing. The screen which I'm sharing it with you is an AWS IoT service where you have thing groups. You can group the things. Maybe we can group. I talked about segmentation and all, right? You can group certain things to a thing group. Then you can deploy certain software to the thing. All these things can be managed from AWS, right? That's a high level picture I wanted to give you. So this is how we are using IoT, right? Like now we are talking about AI and IoT coming together. It is converging, right? Like it's been converging, and it's going to be even more, right? There are a lot of more challenges coming in. AI can be used for IoT attacks also, right? Like you can have a malware which is also AI driven malware, which can potentially create attacks to you. You should be good enough to detect those unwanted attacks and all, right? Real time, you need to detect those threats and work on it. And IoT device, like one thing, the AI model can be go rogue, or some unauthorized model comes in, or we trained with some random ones, which is acting not as expected. Then that's a risk, right? Like that's an additional risk which is coming in. If it is AI, which is going to evolve faster, that attack is also going to be much more serious. Then IoT, right? Like if AI is proper, IoT device, some unauthorized IoT device come in, send out the data, and deceive the AI model. Oh, I am a secure guy. You need to have that security mechanism in this place. So there are a lot of potential risks associated with AI and IoT working together. Especially in security, it becomes more and more evident. Right. So hope you guys are following. So the malwares can be AI-driven malwares. Then we have a lot of issues when unauthorized IoT devices comes into the group, starts behaving. So you need to have lots of checks and balances in place. So let me play you another video, how this AWS IoT in Amazon delivery station.
At AWS, we start our customer engagements for IoT with one simple question.
So the idea here is we have a lot of AWS services which are using within our delivery station, Amazon delivery stations. Our packages are there, associates are there. IoT devices are also being used. AI also being used. I explained, we have seen the video in the previous one. There are a lot of AI models used. Here it's more focused on IoT and what are the services used for this, managing this, right? Most of the challenges would be addressed by these AWS services or any of the IoT services that you have. This would be of good use when you are working with IoT. So let me play this video.
If you knew the state of everything and you could reason on top of that data, what problems would you solve? And we made it our mission to make sure that you can know the state of everything, of all your devices, and that you can reason on top of that data so that you can truly solve your business problems. We help customers like Enel, a power company from Italy that uses AWS as its IoT platform for energy management. They are building AWS IoT and green grass-enabled gateways for homes and the power generation sites, so they can process and act on large volumes of data within milliseconds. Symantec's award-winning router and security solution for homes utilizes AWS IoT in the backend. The mining company Rio Tinto utilizes AWS IoT and Greengrass on their Lotus and the Boron mine. They determine real-time heat maps of road roughness, which allows them to optimize wear and tear on this very heavy equipment and saves millions of dollars. And Philips Healthcare runs its Health Suite digital platform using AWS IoT to help create better healthcare. And these are just a few examples of how AWS IoT is helping a lot of customers solve their business problems. We help them by providing edge-based software, including Amazon FreeRTOS and AWS Greengrass, that allows our customers to securely connect their assets, gather data, and take intelligent actions locally, even when the internet connectivity is down. We help them with cloud-based services, including AWS IoT Core, IoT Device Management, and IoT Device Defender. That allows customers to quickly onboard their large and diverse fleets of devices, maintain fleet health, and keep their fleets secure. We help them reason on top of their IoT data with services like AWS IoT Analytics that allows our customers to easily analyze their IoT data. It also integrates seamlessly with Amazon QuickSight for visualization and Amazon SageMaker, our hosted machine learning service. And last but not least, all AWS IoT services are built serverless, means our customers take the full benefit of the elasticity of the AWS cloud to build their enterprise applications, and they don't have to worry about scalability or utilization, truly only paying for what they really use. So, what does this mean for you? It means that no matter what business or industry you are in, AWS IoT can help you extract value from your connected devices. To understand this a bit better, let's take a deeper look at all the AWS IoT services one by one. Starting at the source, where most of the IoT data is generated, we provide Amazon FreeRTOS, a free open source IoT connected operating system for microcontroller-based edge devices. It extends the market-leading FreeRTOS kernel with software libraries that make it easy to securely connect your small, low-power devices on a local network to more powerful devices running AWS Greengrass, or connect via the internet to AWS IoT Core in the cloud for analysis and action. It also keeps edge devices secure with security credentials and key management, and it keeps your data secure with transport layer encryption. We also provide firmware services for Amazon FreeRTOS with integrated code signing that keeps your devices up to date. For more powerful edge devices like gateways or programmable logic controllers running Linux, we provide a software runtime called AWS Greengrass. Greengrass extends AWS IoT functionality to the edge and installs on your local devices so that they can take local actions quickly at the edge. Using the serverless programming model, you can easily write and test Lambda functions in the cloud and deploy them onto a Greengrass core device, taking benefit from local resources and peripherals these devices offer. Your Greengrass-enabled devices continue to route local messages even when they lose internet connectivity. And when the connectivity is reestablished, they automatically sync data and device state securely with the AWS cloud. AWS Greengrass does this utilizing the very same security mechanisms and encryption used in the cloud with AWS IoT. And it's updatable, so you get access to new features and security enhancements in the future. Along with Amazon FreeRTOS and AWS Greengrass, our cloud-based service, AWS IoT Core, forms the backbone for IoT deployments to securely connect all your devices and handle their data at scale. AWS IoT Core allows you to securely connect devices to the AWS cloud and with each other. It allows you to route, process, and act on the data and messages coming from those devices. And it also allows you to deploy and develop applications that can interact with your devices even when they're offline. Onboarding a few devices is easy. Doing so for millions and keeping your distributed device fleets healthy is much more complicated. That's why we provide AWS IoT Device Management. It helps you onboard new device types and provision them in bulk. It maintains a catalog of device information and configuration, like serial numbers and policies. It also indexes dynamic state information, such as temperature or RPM. You can then query devices based on both static attributes, including firmware versions, as well as dynamic state, such as temperature, in quasi-real time. AWS IoT Device Management monitors your devices to diagnose and troubleshoot issues, and then allows you to remotely perform over-the-air updates to your entire fleet, subfleet, or individual devices. Security has always been our #1 concern at AWS. With AWS IoT Core, you have already built-in device authentication and authorization to keep your IoT solution safe. However, with all the new device types being deployed across so many different environments and locations, it's hard to always know if your security policies are implemented consistently across your entire fleet of devices. That's why we are building AWS IoT Device Defender to continuously audit the policies associated with your devices. It also monitors your device fleet for abnormal behavior that might indicate a potential security issue. And it alerts you if something doesn't look right, like traffic from devices to an unauthorized IP address, or spikes in outbound traffic that might indicate that the device is participating in a DDoS attack. And finally, through its integration with IoT Device Management, IoT Device Defender lets you take corrective actions to keep your devices secure. Now that you can maintain your fleet health and keep it secure, the key question is, how do you generate value from your device data? That's where AWS IoT Analytics comes into play. It is a fully managed analytics service to easily analyze IoT data. It can run analytics on massive volumes of IoT data without having to worry about all the cost and complexity typically required to build your own IoT analytics platform. It filters, transforms, and enriches IoT data before storing it in an IoT-optimized data store. That way, you can easily query your data using the built-in SQL query engine and visualize your outcome using Amazon QuickSight. AWS IoT Analytics also supports more sophisticated analytics by preparing your data for machine learning using pre-built Jupyter Notebook templates of machine learning models that can be trained and run using Amazon SageMaker. And to close the loop, you can deploy your cloud-trained machine learning models to an edge device with AWS Greengrass. That means you can make predictions based on locally generated data without a round trip to the cloud. Application developers can now add machine learning to the devices without having specialized machine learning skills. Finally, we thought about whether there was a way to make it even easier to get started with IoT. Maybe you just want to be able to press a button to get the hotel staff to pick up your dirty dishes from your hotel room. Or on the factory floor, you just want to have a simple button next to your machinery that calls a service team member to fix the machine if something doesn't work. What if you just needed to acquire a device, configure it in a simple way to execute a dedicated action, and it just works? This is how we came up with AWS IoT One-Click, to enable one-click creation of a trigger for an AWS Lambda function for pre-configured simple devices like a sensor or a button. With AWS IoT One-Click, you can select and order devices that ship fully provisioned to securely connect to AWS IoT. You can configure and deploy those devices with just one click via a simple mobile app to take dedicated actions. And you can easily define attributes and extract reports on your devices from the very same mobile app. With the help of AWS IoT, you can know the state of everything and you can reason on top of the data. So, what problem?
So, yep, I have given you a video where hope you can hear me well still, or is there an audio issue? Yeah, so what I said, yes, we have seen IoT AI in different applications, right? Like the last video where you have seen different kind of services available with IoT, which you can use, and a lot of those challenges are solved for you, right? yes, AWS IoT is one such service which can come handy, and we are using in our delivery station architectures for handling the IoT data. So with that, so what are the best practices you need to follow, right? Like with AI and IoT, definitely data encryption, right? Be it training model or be it communication, data should be properly encrypted. We call encryption at rest, encryption at transmission, right? Like it should be properly encrypted so that modifications are not allowed. The validations, like any access control is also important, right? Like who can access the data? That needs to be very well defined. It's not like anybody can go and access. Like there should be proper measures in place. And these are IoT devices. These are models which requires constant updates, right? Like it's not proper accurate. There will be changes which you need to eventually provide a firmware update or software update or feed in different models, different inputs to those models. All those things to be securely handled. So IoT, AI is not 100% accurate all the time, right? It is a prediction based thing. It can eventually make mistakes also, like with some issues. You should be able to detect those also, and we should have proper auditing and logging so that how that decision has been made, which went wrong, so that you can train your model again and evolve. It is a continuous learning basically. So don't trust anything. Like with zero trust, you should start segmenting your networks, IoT networks. Create an architecture which is secure enough to do communicate and train things, right? And access control is also important. So how the future is going to be with AI and IoT, right? This is the current status which you're talking about. Blockchain, for example, right? Like we are going to train data. I was talking about integrity of the data. Blockchain is the place where integrity of the data is maintained, where you has the block. It is a decentralized thing, right? That blocks are stored at different systems in a network, and each are tamper proof. Basically, we have a hash to maintain that block is integer. It's not been modified and all. It's been verified with all the people in that network. So that's how it high level works. I have a video for that also. Because of time constraint, I'm skipping. Maybe we'll come back to that later when time allows. So blockchain is next thing coming in for AI model training models, right? Training data. And so the data from IoT should be untampered, given to AI, or filtered out and given to AI so that AI works efficiently. And we talked about encryption. When you say about encryption, one person, so we have private key, public key based asymmetric encryption and all. So there is a different kind of encryption technology evolving where it is homomorphic encryption, where there is a third key called evaluation key. So without completely decrypting the content, you can do that. We can use that encryption to train the AI or make decisions. To analogy I can give you, let's say you're going for a voting. Everybody has voted things, right? So how do you know that AI model or whatever model has decided the winner properly, right? Maybe it has made some mistakes. So you want to see how it has calculated it. So using the evaluation key, we can able to see that. But the thing there is, it is not going to reveal whom I voted for. Maybe I voted for A or B. That is kind of hidden. The differential privacy is maintained. So that is kind of achieved with the homomorphic encryption, which is a evolving thing, which will play a very critical role in AI and IoT. But it comes with a cost, right? Like the algorithm is complex. It is a costly one because you need to do a lot of competition to do that. And AI should be able to identify the threats in real time and heal the IoT networks automatically. For example, during the runtime, I figure out, okay, certain segment is misbehaving. Let's isolate them. Let's not take any inputs from them, or let's block the communications to and fro. Inbound and outbound communications are blocked. Right? These decisions can be taken at the runtime using AI. That kind of provision is also there. So with that, we can break for 10 or 15 minutes break. We can come back and start. We can start at 7:55. I have a few more things to cover. How architecturally we are evolving, or what are the additional things we need to think about when you're thinking AI for IoT security. Yep. Over to you, ma'am. Like, we can come back when people are ready and start that.
Thank you so much, Mr. Madan, for providing a lot of valuable and useful information to the participants, covering key aspects of protecting IoT devices from cybersecurity threats. Future trends in AI and IoT security. Thank you so much. Let's take a 15 minutes break now and continue the next session. Dear participants, the attendance cum feedback link has been provided in the chat section. Kindly fill out the form before you resume. The participants are requested to kindly return to the session on time after the break. Thank you.
Okay, let's get started again. Sharing the screen. Please confirm if you can see the screen. Can you see my screen? I started sharing. Cool, great. So we talked so much about AI and IoT working together, right? If you look at IoT is generating so much of data, and AI is using those data to process it. Right now, one thing comes: should I give all the data to them, AI model, or should I give as it is? No, like there are some unnecessary things which you don't want to send it to AI model, or there might be things which you want to filter out. There are a lot of aspects to it, right? So for that also we have a service which is doing that. AWS Fleetwise is one such kind. So if you look at, to give you a picture, there could be thousands of devices in a segment, IoT segment. They are all sending data, maybe discovery data, maybe some control data, whatever it is. Now, all those data, you don't need to send it to the model, right? Like maybe you need to filter out, merge those things, and send it as a one batch. Because we are talking about enormous big data, right? Like we have enormous number of data. We don't want to congest our network also. That's where the solution comes in Fleetwise, where you collect the data, filter it, transform it, and transfer the data. Transform, it is required because there could be LED controller as an IoT device. There could be, you can hear me well, right? Just in case if my voice is feeble, let me know. You can have LED strips as a IoT device. You can have other things like conveyor belt as an IoT, a robot as an IoT, right? So everybody is going to send data in different format. The data not necessarily to be in same format, but our IoT, our AI understands, AI model requires certain format of data or need to be transformed in certain way so that they can understand. So that's where the data transformation is important. These are critical layers which will help you to process the data. Intermediate step, proxy, right? Proxy for the data. These collect the data and sends to the model. That's where the AWS Fleetwise is there. Let me play the video also.
Automakers need access to vehicle data to diagnose problems and improve vehicle safety. But unique vehicle data formats require custom data collection systems. And as vehicles advance, they generate more data, making transfer to the cloud increasingly expensive. Introducing AWS IoT Fleetwise. AWS IoT Fleetwise makes it easy to collect, transform, and transfer vehicle data to the cloud in near real time. It removes the heavy lift of building custom data collection systems by simplifying access to each vehicle's unique data format. Intelligent filtering capabilities transfer only high-value data signals to the cloud, which means more useful data at a lower cost. Use data from AWS IoT FleetWise to remotely diagnose vehicle issues in near real time, protecting against warranty claims and recalls. Or use the data to train machine learning models that support advanced driver assistance systems for safer vehicles. Optimize your fleets and minimize costly data collection with AWS IoT FleetWise. Learn more at our website.
Yeah, that's a very brief about AWS FleetWise, right? Which is used in conjunction with IoT and AI. You can read more about it online, but that gives you the picture. I'm covering some general concept which is applicable in architecting things, right? Now comes the next one, right? We talk about data, we talk about so many things, but where do you process it, right? Some computer or some machine needs to process it, right? Any host or any instance. Where do you keep that instance? Our ML models are not simple to run, right? Like that requires certain compute, maybe high power, CPU requirement, memory requirement, GPU requirement. There are a lot of factors coming. And type of instance. Somewhere we require bare metal instances, not virtual instances. So that's how ML models. There are a lot of specific requirements for ML. So you have two options here. One, you can run it in local, meaning if you take delivery station as an example, all your IoT devices are in the delivery station, and your compute, the computer is also in the delivery station. These IoT devices communicate with the computer. That's it. That's an on-premise compute, meaning local edge computing. You have a device sitting in your delivery station where you do the computation. Then the other case is like, no, I will send all the data to cloud. The host or computer will be running in cloud, EC2 instance, basically. Maybe Azure or whatever it is, cloud service, right? So the cloud can run those services. AWS EC2 is one thing, right? You don't manage the hardware. Cloud, the AWS manages the hardware. That's the difference. But in on-premise, you manage the hardware. So these are the different things available, but some models can be run in on-premise, some cannot be. Those things needs to run in cloud. But given that there is a latency difference between cloud and on-premise. If it is in on-premise, you would be getting the response in fast in less than 10 milliseconds, single-digit milliseconds, right? But if it is going to cloud, it will take some time, maybe greater than 40 milliseconds. Depends on how far the compute is, right? So that's high level about the thing. I'm just setting the context so that you will understand how, when I talk about architecture, we talked about FleetWise, we talk about type of compute, cloud computer, on-premise compute. Now let's go next, right? So when you are designing security solutions using AI for IoT, there are a lot of things you need to keep it in mind. What kind of architecture you need to do, like, right? Edge computing or cloud computing, for instance. Firewall, what kind of firewall? What kind of segmentation? There are a lot of things, I think. So in every place, you need to think about security. Be it network, be it data communication, be it testing, be it training, assessing, or however you monitor. The security should be there in every aspect of it, right? So security is very, very important. When you're thinking about AI-based solutions for IoT. Because I called out challenges, right? Based on the kind of model you give, data you give, AI will be give. And you don't want AI to be deceived or hallucinating things, right? When you're talking about authentication by AI, if you say AI will automatically detect I'm the right person or not, right? I'm authorized to access or not, right? Like then that has to be yes or no. It can't be like maybe, right? Like, so that kind of things are there. So where do you apply AI? Where do you don't apply AI? It's all depends on the use case and other factors. So in general, what are these areas AI can be used in IoT, right? Like threat detection. I talked about that briefly. Access control also, I talked about it. Network security. If there is a issue to, if there is a vulnerability, how do you want to automatically detect with the AI, with the behavior, or with the pattern matching, whatever it is, right? With the model. There will be, of course, there will be different kind of model for each of these, but you can use AI for doing these kind of things. One thing which we have not talked about yet is the predictive maintenance. what I really mean by that is, let's say we have these IoT devices in delivery station, conveyor belt, robot, all those things. So those are hardware devices, right? Like our phone, like our uh, personal computer, right? Those are also some hardware, right? Like physical devices that can also go for failure, right? Like it needs constant maintenance to work effectively. So AI can be even applied there to predict, oh, this device has been working on this first time and these many data which has handled. So it is expected to fail in this day. So let's take an action. That kind of resiliency aspects or security aspects can be handled with AI, right? So yes, if that IoT devices are playing critical functionalities like medical monitoring, for example, then it takes much more importance. The predictive maintenance is like of top priority. So yes, AI can be used in a lot of areas in IoT, right? Specifically talking about security. Other than that, applications are enormous. So I talked about all these things at a high level. You need to detect the anomalies in the network. You need to prevent the intrusions. You need to have intelligent authentication and access control mechanisms. If something happens, you want to automatically respond to the situation, right? One of the situation which I called out earlier, maybe you can isolate that particular network segment so that it doesn't interfere with others, right? That kind of automated things can be achieved with AI. Encryption and privacy, those are of key aspects you should consider when you're thinking about AI-based security. So advantages, it learns faster, it learns fast, it can detect the pattern fast. Like everything is like, it's an evolving thing, right? Like day by day it evolves, and our security is going to get better and better. Okay. Having said, there are some corner cases which you need to be thinking about. What if that AI does something wrong? How do you want to handle it? Those kind of things need to be in place. We need to have proper checks and balances, but it can streamline a lot of things and it can help you move faster. So yes, so I talked about security solutions with AI, right, for IoT. But when you talk about solutions, you should talk about risks also, right? Like what are the drawbacks? I wouldn't say like it's 100% effective using AI for security. Like maybe effective in some cases it may not. Depends on the scenario and use case. First of all, it is very costly. You should be able to bear that cost, right? For an application where you can do that authentication with a simple auth service, right? With passport or biometric service and all looks fine. Then you don't need AI, right? Like you need AI if you want to do some advanced authentication mechanisms. If that cost is not giving you any returns, that much of returns, it's not effective. It's not make sense to use that AI, right? It depends on the use case and scenario. First of all, it's very costly. Second, AIs are not accurate all the time. Especially Gen AI is like, it hallucinates a lot of stages, right? It can give false positives, it can give false negatives. Meaning it says something is correct, but it may be false. Or else it can say that some particular thing is wrong, but it may be right, right? So those kind of outcomes are expected, but you need to have lots of other workarounds when that happens. And it's definitely going to create bad experience, right? Let's say I'm going and scanning my face, AI says that you are not authorized, even though you're authorized. It's a very bad experience for a customer. So it needs to be considered thoroughly, right? If you're okay with that, yes, you can think about it. And you need to have lots and lots of data. If you have a AI thing, models is there, but you don't have enough data to train it, it doesn't make sense. You need to have I'm talking about Amazon delivery station because you have so much of data to train the models and apply it, right? Or else you need to go with some generic models. Some of the generic models won't work. It works on the public data, right? Which is not suitable for a use case. So data is a main concern. You need to have data, and depending on the use case, the quality of data and quantity of the data is important. And when you're using AI, the risks of attack are also going. You should be ready to handle all these things when you think about AI-based solutions. So you need to approach in systematic manner, right? Like first evaluate your security landscape, what you need, and research and select appropriate solutions. I talked about AWS IoT core. It solves a lot of things, but it may not solve certain things. So you might need to evaluate other things also, which works best for your use case, and implement a plan. And it's, as I said, it's not proper always. You need to have a proper mechanisms in place to monitor and refine over the course, so that if something goes wrong, what do you do, or how do you come out of that situation, right? It shouldn't be a bottleneck. You implement something with AI, it shouldn't be a bottleneck at the end, right? Like it should work seamlessly. So it is a long way to go. It won't work at the first time. So you should be very careful when you're doing this. Having said that, it's not only about implementing security particular protocol or particular things. It's about where you do the processing, where you keep the IoT device, how do you segment. There are a lot of things in architecture, right? Where network architecture or software architecture, it plays a very key role here, right? As you all know, that architectures have evolved over the time, right? Like initially in 1960s, we were thinking of having only one service which is handling everything, monolith architecture, which evolved to client server. Okay, let's split into two-tier systems, client and server. The client will request the server, server will do the backend processing, client will do the front-end processing. That kind of things came in. That was also not sufficient. Then we evolved over the time. Okay, let's break into multiple services, service-oriented architecture, right? So reusable service. One service can be used for example, let's create an authentication service, auth service, which will be used by delivery station also. That auth service can be used by somewhere outside, maybe used in my home authentication also. So there are a lot of things, right? Like there are reusable things which you can create that came service oriented architecture. Now again, the one more thing, like maybe still the services are like too coupled with a lot of things into one place. We want to scale much more, right? In 2000s, microservice came in. For your information, all your corporate, Amazon, Uber, Netflix, Ola, whatever, name it, Google, everybody follows this microservice architecture, where you create decoupled services, which is focusing on certain tasks, and all these services work together to create a thing. Now that is also changing, right? It's not microservices. Microservice exists, but in conjunction with how do you want to host the services, right? Like, do you want to manage that overhead of manage a host and everything? Cloud became picture, right? I want to write the business logic. I don't want to care about how do you manage the infrastructure. What if that system goes down? Who will spawn the other system? Or who will replace the hardware, RAM? Who will replace the CPU? That headache I don't want. That's where the cloud thing came in. And now, even in cloud, we have two varieties, right? Like we have a EC2 instance running always, meaning that service is running always. When you send a request, it will respond away. The service is like 24/7, it's running. You pay monthly. And there is another thing called serverless architecture. What it means, I don't have a fixed host running everywhere. Whenever I send a request, virtually the AWS will create a new host for you, and it will execute and return the response. Let's say I'm going to do that request only few times in a day. I don't need a complete EC2 instance running all the time. That's where the serverless architecture come in. So in today's world, microservice and cloud serverless architecture are all there, which works in conjunction. Now, IoT is also coming into mix. You can't fit IoT into this monolith client server, that traditional architecture. It needs to work with the latest ones, microservice based or cloud or serverless architecture, right? So that's how architectures are also evolving. Now I talked about two things, right? Like one, earlier I talked about, okay, that server is running in the delivery station. Let's say delivery station as an example, where you have IoT devices in it, LED controllers, robots, all are IoTs in a delivery station. These are going to send and receive data, right? It can send to the host which is hosted in the particular delivery station, that is edge computing. Or you can send it to cloud, right? I told you, edge, it is more secure because it's all local. You can do what you want to share outside, what you don't. Cloud, it's going over the network, internet, and it is reaching the cloud, and you decide what you want to do, what you don't want to do, right? So there is and that's one aspect, right? How do you communicate these data to cloud securely? That's one problem we have. The second problem is latency. If it is local, I would get single digit latency, single digit millisecond. If it is going to cloud, I might get more than that because it's not nearby. It's going over the internet. It needs to pass through so many routers, reach the destination and come back. Right, the same path has to happen again. So it's slightly complicated when you're moving to cloud. The security becomes much more. How do you establish a channel where IoT device and the service hosted in cloud communicate each other without creating any issues? Now, edge computing is standard one, right? Like you have your computer locally, you decide what you want to do, what ML you want to run, what you want to share outside. That's okay. But it comes with this challenge. What if we want to run some multiple ML models, right? Maybe you can't maintain hundreds of local machines, local personal computers, local Linux machines in delivery station to execute that. So now AWS compute is much more important, right? Like where you can, on runtime, you can scale up, you can scale down, you can do a lot of stuff. It gives flexibility. But I said AWS latency increases. But recently, there are a lot more services evolving, right? For example, region, local zone, outpost. So what do you mean by that? Region is like, okay, you have a US region, you have a EU region, you have a EU region. For example, I'm a customer in India. If I'm sending a request, that request is going to reach EU region, which is going to respond. It's a distance wise, it's a thousands of kilometers of distance, right? So the latency is expected, maybe 50 milliseconds. Let's take an example, right? Like hitting a server, sending a request to a server hosted in EU, I'm getting a response in 50 milliseconds. Now that seems more, that won't work, right? I want much faster than that because my application is like that. My IoT device use case is like that. So that's where AWS local zone came in. Now, what is this? It's an extension to region, right? Now, AWS has extended that you have servers in Bangalore, you have servers in Chennai, you have servers in Delhi. I'm from Bangalore right now. I can send requests to, I can host my service in AWS Bangalore, right? Not in AWS EU. Now it's the computer has come closer to me. I would be able to get faster responses. That's the point, right? You might argue that that's also not good enough. I have a lot of network congestions which might introduce delay. Like this is a mission critical information. Let's say you want to launch a rocket, right? I don't want to rely on that. So in those cases, AWS also offers Outpost. Outpost is like thinking in a way that AWS comes and sets up their servers in your home, right? In your area or in your city, where Outpost, but it's managed by AWS though, but it's very, very near to you, maybe in few kilometers, few hundred kilometers, less than 100 kilometers. It'll be even more faster. So there are a lot of options available, right? Like you can host in region, you can host in the sense your application, business logic or ML models, which are going to do this security. So which you are going to do this decision making in security, IoT security, or analyzing the patterns. They can run in different places: region, local zone, outpost, and even local edge computing. So I did call out about AWS Green Gas IoT Core earlier. Those and all work well with these different kind of variants, infrastructures, AWS compute infrastructures to serve our IoT use cases. So I do have a video explaining how to what local zone is. Let me play it along.
Many customers in industries like online gaming, media and entertainment, financial services, healthcare, and the public sector have applications that require single-digit millisecond latency or data residency. When an AWS region isn't close enough or within a geopolitical boundary to meet these requirements, you must provision and manage your own infrastructure while using different APIs and tools than you normally would to build and run your applications. AWS local zones are a new type of infrastructure deployment that places compute, storage, database, and other select AWS services close to large population and industry centers. You can use the services available in a local zone to build and run your applications, and also seamlessly access the full range of AWS services available in the parent region that the AWS local zone is connected to via Amazon's redundant and very high bandwidth private network. Since local zones are managed and supported by AWS, you can get all the elasticity, scalability, and security benefits of the cloud. You can easily build and deploy location-sensitive workloads where you need them, scale them up or down, and pay only for the resources you use. Start using AWS local zones in just a few steps. Open the AWS Management Console or command line interface, enable the local zones of interest, extend your virtual private cloud to them, and then launch EC2 instances, EBS volumes, and other services to run your applications. Get started today with AWS local zones for your latency and location-sensitive workloads.
Cool. That was a very short video about how what local zones is. I did explain about that, right? So, okay, we have decided, okay, I want to use region or local zone or local endpoint in AWS compute, right? Like something I want to host in cloud, which will do the ML processing or training, whatever business logic you want to run. But our IoT devices are still in the ground, in delivery station. These two needs to communicate with each other, right? And this communication should be secure enough. There shouldn't be any intruder. It should be properly. It should go through secure channels. How to now there is a one end where it is cloud, the other end where it is a delivery station. Both are like IP based. Both have their individual IPs, but they need to communicate with each other. And it need not be like they need to be public IP, right? Like why do you give our IoT devices public IP? Public IPs are like very limited. So in the communication are two ways. That's what I'm coming to. IoT device can send message to our compute. Our compute can send message to IoT device. For example, when you scan something in delivery station, you send that scan information to AWS compute, our host, our service. And when to blink that LED, our service hosted in AWS will send that message to the IoT device in delivery station. There is an inbound and outbound connectivity here. That's very important to note. That means both should be able to identify each other, right? Like how do you identify each other? It's based on IP, IPv4, IPv6, whatever IP mechanisms we have. Sometimes it can be only one-way communication. A lot of factors are there. So let's assume that we need to both needs to send a message to each other, but they can't have public IP. I can't have thousands of public IP for one delivery station. Public IP is also costly, right? Like public IP mean which is recognized all over the internet. You would be identified by that particular IP, elastic IP, all over the internet. So that is not feasible. That's not a workaround possible option for us to assign public IP to each of the IoT devices. So now let's assume for a moment you have a private IP for our compute. It's not publicly exposed, and we have a private IP for our IoT devices in the delivery station. But both of them need to communicate with each other. So what is the option? We need to establish a VPN connectivity within them, right? Like that means there is a IPsec tunnel established between these two, and we communicate with them in a secure way, right? That's how you can architect these things so that the data communication between compute and meaning other ways AI and IoT in a very secure way. Be it security based, the decision can be anything, right? Like any use case. It can be a security, it can be a non-security use case, but still the data should be communicated in proper secure channels. So that's where that site-to-site VPN comes. I do have a hands-on thing, which will take some time. Maybe probably I will share this video offline. How do you want to?
Work today is broken.
So how do you physically, it's a hands-on material about how do you set up site-to-site VPN. One in between delivery station and the AWS compute. I'm sharing it in the chat. I'm not playing the video here because of the time constraint, but because if we have time, we will come back to the same. So it's it's a good video where you'll have hands-on experience of how to set up things. Now, okay. So I will go to those videos. Before that, so final thoughts, right? Now we have AI, we talked about AI, we have IoT to improve our lives. And even to be specific, we even talked about security, right? But it comes with a lot of security risks which you need to handle very thoroughly and take the proper decisions accordingly. And protecting the data is very important. Privacy is very important, right? Like it's not like you need to respect the privacy, otherwise the model is not going to work at all. So differential privacy is important, to be very particular. It shouldn't provide any, AI shouldn't be fed in with personally identifiable information, and also it shouldn't give away any privacy related issues to the customers also. AI and IoT grows day by day, right? Like there are a lot of developments happening. So security is definitely our priority. Some things it will work, some things it doesn't, right? Which use case you want to use AI and IoT together? It all comes to it depends on the type of use case. Some of the common security measures which you should always think about: encryption, access control, network, including the networking architecture, whom can communicate with whom, firewall rules, all those things, right? And you shouldn't leave AI to act on its own. It should be continuously monitored. If something goes wrong, you should have a way to defend yourself, proactively stop it. For example, defense can be any two ways, right? Like AI defending the intruder within your network, like isolating a segment, like I called out before, and even some threat you can anticipate and predict about these things. So we should always stay ahead of the evolving threats and ensure a safer digital world. So that's my final thought. I have a couple of videos to play, which I will go. If there are any questions, let me know also. Right. Let me go to about the hands-on, right? Like how do you set up AWS site-to-site VPN? There are a lot of other things, right? Like what protocol it can use to communicate. Yes, it's going to, at the end, it's going to be HTTP, HTTPS, WebSocket-based communications. But on top of that, there are a lot of customer protocols available for IoT, like, for example, A2C, SLAM. It's all dependent on kind of IoT devices. Some IoT device certain protocols. And you need to be establishing those communications with those supported protocols. It's a very complex domain. You need to thread carefully and take a decisions accordingly. Now, I'll be playing this video. It's a considerably, I think more than 5 minutes video where we personally create. We talked about AWS all over the place, right? Here we talk about here we are going to create two things, right? One, our compute in cloud and our IoT devices in on-premise. How these two are going to communicate with each other, right? I told you that site-to-site VPN, right? Like IPsec tunnels between these two are important. How do you do that? It's a hands-on. I have followed this and did the same thing at my end. It was very helpful. I'm just playing the same thing here for everybody's reference. Let's start with this.
So in this lesson, I'm going to show you how to set up an AWS site-to-site virtual private network, a VPN. So this is going to be the topology that we create. We have a VPC, and then we have an on-premises data center. Now, of course, we don't actually have an on-premises data center. So what we're going to do is we're going to use our second account to simulate the on-premises data center. So we have two accounts set up for this course. One is our management account and one is our production account. We're going to use the production account for the on-premises DC. We're going to use the management account for the AWS VPC. We then deploy an EC2 instance into the on-premises DC, and that's going to run a service called OpenSwan, which is an implementation of the IPsec protocol. And the AWS VPN is an IPsec-based VPN. It's the protocol it uses for securing the channel and encrypting the data. So the OpenSwan is essentially going to be the customer gateway. We then have the virtual private gateway on the AWS side. And once we've got those two pieces, we can establish an encrypted virtual private network connection.
So just to give you a picture what these gateways are about. This is a AWS cloud environment. This is an on-premise environment. You need to have a proper VPN connectivity between these IPC communication, right? So it's protected. So for establishing a VPN thing, you need to have gateways at both the ends. So that's what it is about. This is a software-based gateway. This is a hardware gateway. Virtual private gateway is a service offered by AWS also. You can read more about that offline, just to give you the picture that so you'll understand this video better. Thanks.
Between the two data centers. And this will use the public internet because we're going to be using public endpoints for both the VGW and the OpenSwan customer gateway. We'll then need to update our route tables. So the route table in the AWS VPC will have a propagation turned on for the virtual gateway. That means the routes that are advertised via the virtual gateway will be propagated into the route table. On the on-premises DC side, what we're going to do is add an entry, and it's going to point towards the IP cider block of the AWS VPC, and it's going to have a target of the instance ID of the OpenSwan customer gateway. We're then going to launch a couple of instances into our respective sites, and we're going to have an internal server on the on-premises DC side and an EC2 instance on the other side. Of course, they'll both really be EC2 instances. And what we want to do is we're going to try and send a ping request from the internal server, and it's going to use the route table entry and send the data to the OpenSwan customer gateway. And that's going to send it over the encrypted connection to the EC2 instance. And this will be using the private IP address of the EC2 instance. So that's what we're going to do. Let's go and set it up. Now, by the way, I do have some instructions which I'm going to share with you, and they're on this page here. And I'm going to show you every step of the process. You've got to be careful to make sure you follow through carefully. It's not a difficult thing to set up, but if you miss any of these steps, it won't work. So make sure you follow along carefully, and then you can use this as a reference point as well. So the first thing is we're going to go to our on-premises VPC, which remember is our production account, and launch an EC2 instance. And we have a few parameters here. We need to disable source destination checks. That means that we are able to route via the actual EC2 instance because it's not going to check the IP addresses that are coming in and going out. Now, if you don't have that disabled, you can't use IP forwarding with an EC2 instance. We're going to put it in a public subnet so that we can SSH straight into it. And so we need the port 22 open, and we need ICMP all as well so that we can ping both from the AWS VPC to this instance across the VPN. And we want to be able to send the other way as well, which will be the security group on the other side. Once we've done that, we'll take a note of the public IP, come back to the management account and start setting up some stuff there. So let's go and do step one first. I'm in EC2, but at the moment I'm on my management account. So I'm going to switch to my other account, my production account. We're going to launch an instance, Linux 2 AMI, T2 micro. Now let's launch two because one will be our OpenSwan server. The other will be that server we're going to use for testing. So I want to make sure I've got the right VPC selected. And in this case I have, and I've labeled my VPC. So it says on-premises DC, just to make it a bit clearer. I'm going to put them into one subnet here, US East 1A. And you've noticed I'm using North Virginia. So I'm using North Virginia for both sides of the connection. And that just makes it easier flicking between consoles. Also, if you left your VPC peering connection up with Ohio, then we don't want to use that one because we'll have to take down that connection first. So I've got my on-premises DC selected, a public subnet. I've got two instances, and that's all I need to set up. Let's go through. I want to make sure I have a security group that allows SSH, port 22 from anywhere, and ICMP v4 using the IP anywhere as well for IPv4. So make sure you have a security group allowing those two things. If you don't, then just create one. And then let's go and launch those instances. So those are launching. Now let's give one of them the name OpenSwan so we know what it is. And let's just call the other one server and click on save. So what we want now is for the OpenSwan server, go up to actions, networking, change source destination check, and we want to click on stop. So you have to do this if the instance is going to be forwarding connections. So let's click on save. And now we're going to copy the public. Now let's switch back to our other account, so our management account, which is going to be the AWS side of this connection. And while we're in EC2, let's launch the instance that we're going to use for testing on this side. Again, just the same settings as always. I'm going to put this one into my custom VPC. So I've labeled this now AWS VPC. This is the one we created earlier in the course. That should have the 10.0.0.0/16 CIDR block. I'm going to put this one in a public subnet. Doesn't matter too much unless we want to connect in and actually use it for testing from that side of the connection. Let's go through again to security group. I'm going to choose web access. And again, we have SSH and we have ICMP IPv4 all from any source address. So that's great. That's all I need. Let's launch this instance. Let's go to the VPC management console now. And we're going to start setting up the connection. So we scroll down to virtual private network. First thing we'll do is create the customer gateway. Create customer gateway. I'm going to put in the IP address that I copied to my clipboard. So this is the public IP address of the EC2 instance we launched in the production account, the one we labeled OpenSwan. I'm going to give the customer gateway a name, and we don't need to specify any other settings. Make sure rounding's on static and create customer gateway. So that's done. The next is to create a virtual private gateway. So we create virtual private gateway, give it a name tag, and then create the virtual private gateway. Close here, and then what we need to do is attach it to a VPC. So we go to Actions, Attach to VPC, select our AWS VPC, and attach. That's in an attaching state. And the last thing to do is go to site-to-site VPN connections and create the connection. We'll give it a name. The target should be a virtual private gateway. If we select in the box here, we can see the gateway we just created. Then we're going to use an existing customer gateway. Again, select the entry there. Change routing to static. And for prefixes, there's two prefixes we need to add. The 172.31.0.0.16 is from the customer side of the connection. And then the 10.0.0.0/16 is from the AWS VPC side. Now we need to give it the local IPv4 network CIDR. This is the customer gateway side. So that's going to be that 172.31 block. The remote network, that's actually the AWS side. So we can copy that down there. And that's those two set up. So let's now create this VPN connection. Close out of there, and that's in a pending state. Now, while that's happening, what I'm going to do is go up to route tables, and we need to enable route propagation. I'm going to choose my main route table. This is the route table associated with the AWS VPC. Choose route propagation, edit, and then select propagate. And this is the virtual private gateway here. So we're now going to propagate the routes from the virtual private gateway. Let's click on save. With that done, we can come back down to site-to-site VPN connections. Let's give this a refresh. Still in a pending state, but let's try and download the configuration. We want to choose OpenSwan. So just scroll down to OpenSwan, click on download. That should give you a file that looks very much like this. Now, if it doesn't, it might tell you that it's not ready to generate it and there won't be anything in there. In that case, just wait and try it again a few minutes later. But what you should see is this. And what we're going to do now is if you scroll down to IPsec tunnel 1, we're just going to configure tunnel 1, not tunnel 2. So there's a few instructions here. You'll see these as well in the document in the course download. So these are configurations that we need to apply to the OpenSwan server. That's the one running the IPsec protocol. It's our customer gateway on the production side of the connection. So let's go and SSH into that server. So I've established a connection to my EC2 instance. So again, this is the OpenSwan server in our production DC, which is our on-premises DC that we're simulating. And now let's go and grab some of those commands and start entering the commands. The first one we need to do is open this file here and enter this information. So let's copy this to our clipboard, come back. I'm going to use the nano utility. In fact, before I do that, I've got to switch to root. Then use Nano to edit the file. Just bring the cursor down underneath this text. And then we need to copy this information here. Paste that in. Let's save those entries. And now come back, and to apply those changes, we can run this command. So let's put this in, and we can see that the information has been applied. Now, we don't need to do step 2 because I'm sure that this line is already uncommented. Step 4 is to add this information to this file here, the etc ipsecd AWS conf. But before we do that, we have to install OpenSwan. So coming back to my file here, and you can see I've got these steps in here. So this is the command we need to run, yum install OpenSwan-y. So let's paste that in, and that will install OpenSwan. Now we've already done this next piece here. So we can come down now to this line here where we're nanoing and we're editing this AWS conf file. So we open this file, and you can see it doesn't already exist, so it's empty. Now, the easiest way to get the information to put into here is back on the text file that you downloaded, the configuration file. So this is the information. Now, a couple of things. This line here, auth equals ESB. We've got to remove that. Take that out. It's really important you do that. Then the left subnet, this is the local network behind your OpenSwan server. So that's 172.31.0.0/16. The remote network is the 10.0.0.0/16. That's the AWS side. Now, this has pre-populated the other information. So we've got these IP addresses here already. So we can now copy all of this, paste it in, save the file, and then let's see what the next one is. So the next file, and again, you need to pull this information out of this text file because this is the up-to-date information. We need to edit this secrets file. So let's come back, use Nano, and then we need to copy this line here from the first IP address. So these are the IP address endpoints for our 2 sides of the connection. And then this is the pre-shared key that's being used for authentication. So we just put that whole line in and then save the file. So back in this instructions file, we've just added this information here. We've just added the line to the secrets file, and now we can start IPsec. So let's run the command to start IPsec. Looks like it started, but we can come back and run this command to check the status. And that looks like it's active and running. So things are good there. Now let's go over to the console and see what we've got there. Hopefully we've got a connection which is running. We should have tunnel 1, which is up rather than down. Back in the management account, this is our VPN connection. Let's go to tunnel details, and we can see tunnel 1 is up. So we only configured 1 tunnel, so that looks good. Now, if it still says down, then just give it a minute, give it at least a couple of minutes and keep refreshing, because sometimes it does take a while to show that it's up. Now, if that doesn't happen still, go back and check every step because something along the way has not been executed correctly. So, you might have some configuration problem that you need to resolve. But this one is up. And what I want to do now is let's go back to EC2, and I'm going to go and copy the IP address. So this is the IP address, the private IP address of our instance on the AWS VPC. Let's try and ping that address, and we get a good response. So back in our diagram, what we've done, we've set up the OpenSwan server, the virtual private gateway, the custom gateway, which is a logical object we create here in the VPC, but it corresponds to the actual EC2 instance here. Then we've established a VPN connection. We've updated the route propagation, and what we're going to do is add an entry to the route table so we can ping from our internal server. But what we just did was ping from the OpenSwan instance itself, and we were able to ping this EC2 instance using its private IP address. So that tells us it's definitely going over the VPN connection. So the final test is we're going to add an entry to our route table in the on-premises DC, and then we're going to SSH into the internal server and see if we can ping from there to the EC2 instance, which will mean it's using the route table entry, it's pointing to the OpenSwan server, and then it's sending it on to the EC2 instance. So back in the console here, what I'm going to do is switch accounts again. Let's go to route tables. We've only got one. Go to routes, edit routes, and we're going to add a route. And this is going to be for the 10.0.0.0/16 network. and it's going to go to an EC2 instance. So we've got instance here, let's choose instance, and it will find our instances, and the route should point towards the OpenSwan server. Let's save that route. That's great. Now let's go to EC2, get the IP address and connect in. So back in EC2, I'm going to connect to my server. So I need its public IP address for the SSH connection. And then I'm going to go to a command prompt and connect via SSH. I'm on the command prompt now. And as you can see, I'm logged into a different instance. This one is the server, the on-premises server that we're simulating. And so what I'm going to do is try and ping the IP of the instance that's in the AWS VPC. So let's ping that one and I get a response. So that's great. So that's it, guys. We've completed this lab successfully. We've been able to send a ping request from our internal server. It's used this route table entry to point to the instance ID of the OpenSwan server, which is functioning as our customer gateway. And then there's an established VPN connection through to the AWS side. And it's been able to ping this instance here. So that's all of it. Now, let's just go and remove the configuration. Of course, if you want to, you can play around a bit more and work.
Yep. So that was a demo about how do you create this site-to-site VPN. The key things to note: one end is in delivery station, other end is in cloud, right? And that means IoT devices are at one end, and our machine learning model runs in other end. We kind of established a secure communication using IPsec tunnels. Yes, you need to think about, there is a tunnel 0, we have tunnel 1, one tunnel we have shown it. You also need to establish redundant tunnels. If that tunnel goes down, you fall back to the other ones. So those aspects also come into picture. So that covers it. I can play one more thing, the final ones in a closing thought, where it covers AI and IoT, how it is working in delivery stations. Let me go on video. But before that, if there are any questions, I'm ready to take the questions. Let me know, or else I will go ahead and play the other video.
Ever wonder how Amazon?
Any questions? So I would like to thank the organizers, everyone who participated. Hopefully it was a useful session for you. You are able to follow things. I try to put contents in a way that it is structured and it is useful for everyone. Yes, there might be some things, particularly demo and other aspects, which we have went fast because of the time, but you can always go back and refer to those recordings. Those are openly available, and in fact refer to this recordings also, this meeting recording also. Hopefully it was helpful for all of you. Thank you so much. I'm just playing this last video and letting it over to the organizers.
Forecasting and ordering before anything arrives to the FC. Powered by AWS, Amazon's forecasting engine is used for over 400 million products daily. Let's go to the receiving area. As you'll see, we put a lot of energy into our logistics. It's a symphony of people, AWS, software, and other high-tech components. The result is a coordination between our great employees and the finely honed computer systems we've evolved for more than 20 years. Our employees are the heart and soul of our operation. Some are military veterans. Some are active members of the community. Some are employees that work here with their loved ones. They're all amazing. Trailers full of vendor and small and medium business seller items arrive at these bay doors by appointment. Employees unload the trailers and begin the process of staging items located at their receiving workstations. This FC carries millions of items of inventory, and using the service known as Amazon Aurora, we manage our inventory transactions and other relational database needs. At this station, you can see how our inbound associate receives a product and how those products are stowed in our inventory. Amazon robotic drive units are activated when an associate logs into their workstation to perform their task. Storage pods arrive facing the correct side to stow items into inventory. Every time an associate touches a product, they scan a unique barcode for that item, which we call the Amazon Standard Identification Number, or ASIN. That's stored in our inventory system, so we know what the quantity and location of that item is at any given time. To manage our inventory history, we use Amazon Neptune, a fast, reliable, fully managed graph database service from AWS. Now, you might expect that we'd organize this in a way where similar items are stowed together. For example, all electronics would be stored in the same section. However, at Amazon, we've found that it's more efficient to stow products using a randomized method. That's why you'll see a variety of items in each inventory bin. Once that process has been completed, a physical and digital match is created in our systems. So just a few seconds after an item is stowed, you can order it on Amazon.com. Looking at a station next door, we see a great example of computer vision helping with automation. When an associate scans an item, you'll see magenta lights over some of the bins in the pod. This lets the associate know not to place that item in those locations, as artificial intelligence-driven logic has determined that the bin is full, that placing an item there may negatively impact the pod's overall weight distribution, or that a visually similar item is there and may cause confusion later when an associate needs to pick the item. The associate can then place the item in any of the other bins. But computer vision doesn't stop there. It will also detect what bin the associate reached into and knows where that item is placed. As one final step, it will take a picture of the pod and use image recognition to count the number of items in the bin, making sure the count matches what is recorded in our tracking systems. When the machine learning model has low confidence, it sends images to people to classify and train more ground truth data for our machine learning model, which operates in Amazon SageMaker and Amazon SageMaker Ground Truth from AWS. This allows us to perform ongoing inventory reconciliation, avoiding the scheduled inventory counts that are often done at least once a year at other organizations. Now, what's up with those robots we see moving the pods around? There are thousands of robot drive units spread throughout each floor, helping associates fulfill customer orders daily. Amazon Robotics operate in dedicated fenced-off areas within the FC, which account for about 65% of the facility's total square footage. The drive units travel to various locations in our FC to pick up mobile shelves of product and deliver them to employees who are working at ergonomic workstations. To navigate, they read 2D barcodes on the floor, and locations are tracked in real time using our own created robotic operating software. Our Amazon Robotics team has developed more than 100 services to support operations and uses AWS extensively in the Amazon fulfillment centers. Only specially trained individuals wearing custom safety equipment are allowed to enter this area, but on our virtual tour, we're allowed to walk through this restricted area. Each sortable FC has over 1 million unique items, helping us with our goal to provide Earth's largest selection. You may be thinking, okay, robots are great, but I just ordered an item. How's it picked? To answer that, let's go to a pick station. Here we see a similar layout as our stow station. Once you hit the buy button on Amazon.com, our systems will cue the robots to find the inventory pod with the item you ordered. Once that item has been identified, the robot will bring it to our associate. A screen at the associate station will show them a picture and quantity of the item they need to pick. The same visual bin inspection system is used as during stow, except this time, instead of lighting up bins where items should not be placed, the system lights up in a white light where that item is. The associate identifies and grabs the item, placing it in the yellow tote signified by the green light, and pushes the button, acknowledging that the item was placed there. When the system detects that the tote is full, the light flashes and the associate pushes the full tote back to a series of conveyors and replaces it with a new one that was automatically brought to their station. At this stage, associates are picking items for different customers in batches. The two types of picking processes we focus on are single item orders and multiple item orders. The single item orders contain only one item per customer order. We fill up a yellow tote full of single item orders weighing up to 25 pounds. The single item order yellow totes will then be routed to the singles pack lines for packaging. The multiple item orders contain more than one item per order. If your multiple item order of 6 items are all in this building, then it's possible that your order is being picked up by up to 6 different people picking items from 6 different robots, which all need to be brought together for your single shipment. Your items will be placed in any available yellow tote and routed to our multiple item order assembly stations. It's at that point that we will reap in your individual items into one customer order. Then, once all of your items are together, it's packing time. To help improve efficiency and also reduce environmental impact of the packaging, the size of box or envelope is automatically selected by a machine learning algorithm. Even the correct length of tape is determined by machine learning and automatically dispensed. If needed, protected packaging materials are added. A barcode is placed on the package, it's sealed up, and away we go. That barcode will be important for the next stage that we call SLAM. But what if I order 2 items and those items are in 2 different FCs? Do I get 1 box or 2? The answer is, it depends. Our first priority is to get you the item at the date and time that we promised when you placed the order. The second priority is to do that at the lowest cost possible and with the lowest environmental impact so we can continue to pass on lower prices to you. With those 2 things in mind, we use machine learning to figure out if it's optimal to ship to you from each FC in 2 different packages, or ship an item from one FC to the other, combine them there, and ship to you in a single package. You're now seeing our SLAM line in process. SLAM is an acronym which stands for Scan, Label, Apply, and Manifest. The technology here scans that barcoded sticker placed on the package and pack, and immediately knows to print the correct shipping label on the package. This is the first time your name and address are placed on the package. So how do we know which carrier to use? That's also determined by machine learning. In the space of a few seconds, an algorithm is run to determine the optimal delivery carrier to get you the package on time and at the lowest cost possible. There are also quality control measures in place here. Following this, the box is weighed, and the weight is checked against the item's known weight. If the weight is off, the order will be routed to a special location. From there, an associate will open the package and take the applicable action. We're now entering the final stages. After passing all of those quality control measures, the package is routed onto another series of conveyors to a location where the label is scanned. The conveyors then automatically send each package down the correct chute, where it will be packaged on a semi-trailer for shipment to another FC, or a sortation center for final delivery to you. There are approximately 17.5 miles of conveyor belts in this FC. In order to run reliably, every single day, they're monitored via AWS IoT services. AWS IoT Greengrass helps here by allowing devices to act locally on the data they generate while still taking advantage of the cloud. Events, in particular from the machinery, are sent to Lambda functions in AWS that trigger step functions. These workflows then coordinate RME operations to maintain the equipment, perform inspections, replace faulty motors and belts, and other types of activities. We even collaborate with some of our automation suppliers using AWS ML models to predict equipment failures and address issues before they arise. Thank you for visiting our Amazon Sortable Robotics Fulfillment Center. We hope you enjoyed our
Okay, thank you so much, everyone. Over to you, ma'am.
Thank you very much, Mr. Madan Kumar, for a very informative and engaging practical session. Being a teacher, I should appreciate the effort you put in preparing this session, and your interactive nature convey complex concepts in a clear and interesting manner. On behalf of Department of Computer Networking and PSG Polytechnic College, I extend a very big thanks for accepting our invitation and visiting us virtually. Thank you. Thank you so much.
Thank you.
Dear participants, as we are approaching the final day of our program leading up to the valedictory function tomorrow, we want to remind you all a few important details regarding the oral feedback and the online test. We will be conducting oral feedback sessions tomorrow. This is an opportunity for you to share your thoughts and reflections on the program, as well as for us to provide you with the constructive feedback on your journey. Your input is invaluable to us. And regarding the online test, the test would be conducted tomorrow. You have to log on to the Atal portal and take up the test after the last session. If you encounter any technical issues, please reach out to us immediately. Dear participants, the attendance cum feedback form has been posted in the chat section. Please fill out the form before you leave. Thank you. Thank you for your participation and commitment throughout the sessions. Dear participants, the practice test questions for these days also posted in the chat section. I request all of you to try that before attending the final test. Thank you.